Hi, and welcome to our last level 1 algebra video. Hooray! In this video, we're going to continue talking about algebraic patterns. Remember, algebraic patterns is where we turn numerical patterns into rules. We've looked at linear and exponential in the first part of this video, and now we're going to turn our attention to quadratic patterns. These are a little bit trickier. All right, well, we've only got one example to show you, so let's get into it. Find the algebraic rule for the following number pattern. You can see 2 plus 4 gives 6, 6 plus 6 makes 12, 12 plus 8 makes 20, 20 plus 10 makes 30. So the numbers are not going up the same amount, which means it's not linear, and they're not doubling like the exponential pattern we looked at in the last video. Quadratic pattern. They are a quadratic pattern. Not every pattern is going to be quadratic, although in saying that they will be in the exam because they are only going to test linear, exponential, and quadratic. But I'm saying in real life, if you're looking at a pattern and you think it's quadratic, it may not be. All right, here's the quadratic pattern rule. Y is equal to some number a times x squared plus some number b times x plus some number c. Right, well, let's look at these numbers here. Hopefully you've figured out from these numbers that they are increasing by 2. This is actually called the second difference. The first difference are the numbers in green, and the second difference is what the numbers in green increase by. Now, to work out the number a, we need to half the second difference. Well, we've figured out that the second difference is the number 2, and half of that is 1. So the number a is equal to 1. So far in my rule, I have y equal to 1, which is the number of a, times x squared, plus bx plus c. Right, let's move on. And next thing to do is actually work out c. And like the linear pattern, c is the number at the beginning of the pattern, the 0th number. In this example, the 0th number would actually be 0. Because if we go backwards, 30 minus 10 is 20, minus 8 is 12, minus 6 is 6, minus 4 is 2, minus 2 takes us back to 0. So in this example, C happens to be 0. Right, well, that leaves us just B to figure out. And to find out B, the way I do it is to pick any number from our original pattern. I'm going to pick the number 20. Which is my 4th number in the pattern. So I'm going to substitute 20 into my y value, and I'm going to substitute the number 4 because 20 happens to be the 4th number every time I see x. So I'm going to solve this equation to get b. 20 is equal to 1 times 4 squared plus b times 4 plus 0. And let's tidy this up. We get 20 is equal to 16 plus 4b. If we minus 16 on both sides and divide by 4, you'll eventually work out that b has to be the number 1. So in this example, we've also figured out that b is the number 1. So our final rule, y equals 1x squared plus 1x plus 0. We don't need to write the 1s in front of the x's because those coefficients of 1 are never written, and we don't need to write the plus 0, so we're going to simplify it down to y equals x squared plus x. So that's the rule for this pattern of numbers. Let's check it once again. When x is 1, the first number in the pattern, we need to go 1 squared plus 1, which is 2. When x is 2, the second number in the pattern, we're going to go 2 squared plus 2, which is 6. That's correct. What about when x is 3? 3 squared plus 3 is 12. That is correct. What about the fourth number? What about the fifth number in the pattern? 5 squared plus 5? Yes, that works as well. So we now know the rule works. So let's fast forward to the 10th number in the pattern and go 10 squared plus 10, which is 110. So the 10th number in that pattern would be 110. Great, thanks for watching.